Alright, this is a video on Half-Life. I'm going to have three different problems here, solving for three different types of variables. We'll go and start with the first one. If I have 100.0 grams of carbon-14 that decays until only 25.0 grams of carbon is left, and it took 11,460 years, what is the half-life of carbon-14? So the first thing that I'm going to want to determine is how many half-lives have occurred, because I know if I start with 100 grams and it decays to 25, then I can determine how many half-lives by just taking 100 and I cut that in half and that gets me to 50. I cut that in half again, that gets me to 25. So there's one half-life, two half-lives. So I had two half-lives. Okay? Well, those two half-lives took 11,460 years to undergo two half-lives. If I want to know how long each half-life is, I'm going to divide 11,460 divided by 2, and that will give me the number of years per half-life, and the answer being 5,730 years per half-life. You can use the per half-life unit, or you can just say years. Usually it's just giving years, because if they're asking for a half-life, it's usually a unit of time. Okay, this one's a little different. We're solving for a different variable. This time we're going to solve for how long it's going to take in order for a decay to occur. So thallium-208 has a half-life of 3.053 minutes. How long will it take for 120 grams to decay to 7.50 grams? Okay, so again, in order to find out really anything in this problem, I need to know how many half-lives have occurred. Okay, so I can go from 120, right, and then 120 gets cut in half to 60, 60 gets cut in half to 30, 30 gets cut in half to 15, and then 15 will get cut in half to 7.5. So 1, 2, 3, 4. I had 4 half-lives here. Okay, so if 4 half-lives have elapsed and each half-life is 3.053 seconds, if I want to know how long the total time is in order for this decay to occur, I would simply multiply 4 half-lives by 3.053 minutes, right? Remember, like, this is another unit, could be minute per half-life, and then because of that, my unit of half-life will cancel out. I'm left with just minutes. Okay? So when I do that math, I'll end up with 12.212, but you can just put 12.2 minutes. Okay? All right, our last one is, again, solving for a different type of variable. Here I'm actually going to solve for a mass. Potassium-42 has a half-life of 12.4 hours. How much of an 848-gram sample of potassium-42 will be left after 62.0 hours? So again, in order to find out anything about this problem and to really find out what I'm looking for, which is how much is going to be left over, right, I need to know how many half-lives. Well, in the last two problems, we've discussed how to get half-life based on the decay amounts. Well, here, now I have two amounts of time. So I can also determine the amount of half-lives by doing a division of our time. So if the total time is equal to 62.0 hours, and each half-life time is equal to 12.4 hours, okay, I can just divide that right there, and it'll give me the number of half-lives. In this case, the number of half-lives, if I take 62.0, I divide it by 12.4, I'm going to get 5 half-lives. All right? Now, after 5 half-lives, right now that I know that it's half-lives, after 5 half-lives, how much of an 848-gram sample would be left over? So I'll simply grab 848, okay, that's what I started with, and I'm going to cut that in half, and that'll be 424. And then I'll cut it in half again, and that'll be 212. And then I'll cut it in half again, and that'll be 106. cut that in half again, that'll be 53. Okay, and now you have 1, 2, 3, 4 half-lives. Okay, I need 5 half-lives, so I need one more, and that would be 20. What would it be? 25 point. Oh no, sure. 26.5. 26.5 grams would be what was left over. Okay, so like I said with these, it's not about, finding an equation and plugging in the answers. It's to logically look at the question and find out what's being presented, and using that information to find what you need. Obviously, in order to understand these problems, you need to know what a half-life is by definition. Okay, if you don't, then you really don't know where to start, because if you were looking at all three of these problems, the common step that I did for each one of these, okay, let's go back one more, come on, there we go, is I found out how many half-lives. Right here, how many half-lives? Here, how many half-lives? So for every single type of problem you're going to need to know is you need to find out how many half-lives there are, and you're really not going to be able to do that unless you know what a half-life is. Once you know what a half-life is and you know how many half-lives have occurred in the problem, this problem becomes, and every problem becomes much, much easier.